Hello everyone, I'm Teacher Al. Welcome to my channel. Okay, today we're going to study distance problem for grade 7. Okay, we have now number 3 problem. Mr. Rivera headed south driving his car 60 kilometers per hour. After 30 minutes, his son followed driving another car at a rate of 70 kilometers per hour. How long will it take Mr. Rivera's son to overtake him? So this problem asking for the time to overtake Mr. Rivera's sons. Okay, our solution, we have to pick up first the given. The given Mr. Rivera rate is 60 kilometers per hour plus 1/2 hours. Then sun rate is 70 kilometers per hour. Our representation, let x be the time traveled of the sun, and then x plus 1/2 be the time traveled of Mr. Rivera. And our equation, distance traveled of Mr. Rivera is equals to distance traveled of the sun. To solve the equation, since we have the distance is equals to RT, and equals to RT. Then we have to substitute the rate of the Mr. Rivera is 60, and the time covered by Mr. Rivera is x plus 1/2 equals the rate of the sun is 70 times x. We use x because the time travel of the sun is x. Okay, then next is we're going to simplify. I will use the distributive property. 60 times x equals 60x. 60 times 1 equals 60 divided by 2 equals 30 equals 70x. And then we have to transpose all the variable to the left side of the equation and the constant to the right side of the equation. Okay, 6x, then 70x transposed to the left side of the equation becomes negative 70x equals the positive 30 becomes now negative 30, because when we transpose we're going to change the sign. And now next is to simplify. 6x minus 70x equals negative 10x equals negative 30. Okay, we're going to divide both sides by negative 10, and our x now is negative 10x divided by negative 10 equals x equals negative 30 divided by negative 10 equals 3. So therefore, the time travel covered by the sun is 3 hours. Our complete answer, 3 hours times of sun to overtake Mr. Rivera. Okay, we have another problem. Carla is driving 50 kilometers per hour. How far will she travel in 4 hours? Letter A. B was 6.5 hours, and C 20 minutes, and D Y minutes. So the problem now asking what is the travel time? What is the distance covered? If for letter A, the hours is 4 hours. Okay, we will use our solution. We will use D equals RT for letter A. Then the given the rate is 50 kilometers per hour. Then we are going to multiply by time, which is 4 hours covered in letter A. And then 50 times 4, we're going to multiply, becomes 20 kilometers per hour, the distance covered by letter A. For letter B, we have the same formula that we're going to use. D equals RT equals 50 again, the rate kilometers per hour given. Then the time covered is 6.5. Then we're going to we are going to multiply 50, then the 6.5, which is mixed number, we will change this to improper fraction. Then we're going to multiply 50 times 13 divided by 2. So the result is 325 kilometers is the distance for letter B. And for letter C, D equals RT again, our formula. Then the same kilometers per hour, covered is 50, and 20 minutes, it's about to divide by 60 because our rate is and state and hour. That's why we're going to divide it by 60 minutes. So our to simplify now, 50 times 200 divided by 60, we have 1060. Then 1000 divided by 60, we have 16.67 kilometers covered. And letter C. Okay, letter D. Letter D, we have the same formula that we're going to use. D equals RT, then equals the same rate, 50 kilometers. And the time is Y. So our since Y is minutes, so we're going to divide it by 60. So then we're going to multiply 50 times Y divided by 60. So our answer is 50Y over 60. Then we're going to divide it by 10. So that's why our final answer is 50 over 6 Y kilometers. That's for letter D. Okay, we have number 2 problem. Carlo traveled 260 kilometers. What was his rate if he made the trip in 10 hours? For B, 4 hours. And C, Y hour. So in this problem, asking for the rate of travel or the speed of travel by Carlo. So our solution for letter A, we're going to use again the common formula D equals RT. So since the given is the distance 260 kilometers, we're going to substitute for D 260 equals R not yet given, but the time is given to 10 hours. Then we're going to multiply 260 bring down equals R times 10 equals 10 hour. Then we're going to divide both sides by 10, and 10 divided by 10 equals R, and 260 divided by 10 equals 26. So therefore for letter A, the rate is 26 kilometers per hour. For letter B, the same formula that we're going to use, D equals RT. D is 260, the distance, equals, for letter B, the hour covered is only 4 hours. Then we're going to multiply 4 times R equals 4 hour. Then we're going to divide it by 4, both sides. So that's why 4 divided by 4 equals R, and 260 divided by 4 equals 65. So therefore, the rate of letter B, if Carlo traveled for 4 hours, is 65 kilometers per hour. And for letter C, the same formula that we're going to use, D equals RT, and the given distance is 260 equals R times Y. Because for letter C, Y, R is the given. Then 260 equals R times Y equals YR. And we're going to multiply both sides by Y. So that's why our rate for letter C, R equals 260 over Y kilometers per hour. Okay, another problem, number 3. Marlon traveled 360 miles. How long did it take him if his rate was A, 50 miles per hour, 60 miles per hour, and letter C, ZM miles per hour? Okay, in this problem, asking for the time travel of Marlon, which is covered for 360 miles. Okay, that's the distance. Now our solution, the same. We're going to use the formula D equals RT. Since the distance is given, we're going to substitute for D, becomes 360 equals, the rate is also given. For letter A, we have 50 times T. And then, since we're going to compute for the time, we're going to divide both sides by 50. And 50 divided by 50 equals T. And 360 divided by 50 equals 7.2 hours. So therefore, for letter A, the time travel covered by Marlon is 7.2 hours. For letter B, the same formula that we're going to use, D equals RT, and we're going to substitute for D given in the problem is 360 the distance, and the rate is also given for letter B with is 60 and T, and we're going to solve for the time troubled. So we're going to divide both sides by 60. 60 divided by 60 equals t, and 360 equals 60 equals 6 hours. So therefore the time troubled for Marlon and letter B is 6 hours. For letter C, D equals RT, and the distance given, so we're going to substitute 360 equals ZZ. Then 360 we're going to divide it by both sides by Z, and Z divided by Z equals T. And now our time is 360 divided by Z hours. So therefore the time travel covered by Marlon in letter Z, in letter C rather, T is equals 360 over Z. Well, welcome to my channel. Today we're going to study again mathematics about measures of central tendency of ungrouped data, grade 7. The problem number 1 is about a group of teachers in the school of Bacoor conducted a study on the number of absences incurred by their students on the first 2 quarters of the school year 2020-2021. A random sample of 15 students showed the following data: 2, 4, 6, 8, 5, 5, 5, 6, 5, 7, 7, 8, 8, 9, 9. And the questions here, find the mean of the data set. To find the mean of measures of central tendency, we have to add all the given sample data. Then we have to divide it by the number of samples. So the number of samples is 15, and now we're going to add 2 plus 4 plus 6 plus 8 plus 5 plus 5 plus 5 plus 6 plus 5 plus 7 plus 7 plus 8 plus 8 plus 9 plus 9. The x bar means the x bar is the mean, equals to 94 over 15. Then we're going to divide it 6.27, or 6 because we're going to round up, because we're talking by a certain person. There's no half naman sa a certain person. That's why we need the whole number. Therefore, this means the average number of absences incurred by a 15 student is